noisy room here with a lot of other professors, instructors from UAA. I noticed though that this background noise doesn't seem to be recorded. Anyway, let's go. I want to explain a few things. What you see here, chapter 1.1, angles, degrees, and special triangles, and then the problems are listed on page 10, and then these are the problems I'm going to go over. That is only the case if we use the book by McKeag and Turner called Trigonometry, 5th edition. If in a future semester we don't use this book anymore, if we use a different book, then of course the page numbers and the chapter numbers would be different. Even if we use the 6th edition from Trigonometry, the page numbers would be still off. That's why I use these designations A and B and C. Pay attention to these ABC exercises only, not to the page numbers, page and chapter numbers. I will not put this disclaimer into every session here, but just be aware of it. I like to reuse my recorded sessions because they're a lot of work, and I don't want to have to tape 50 hours of work every time I change the textbook. So let's get started. We're going to do these exercises, A, B, C, D, E, F. These are, what you see here, these are just going to help me somewhat, just in case I need a square root, or I need a square, or I need a cube, or I need an approximate sign. They're just there. They're pretty handy for me. Okay, let's get started. Problem A says to indicate which of the angles below are acute and which are obtuse angles, then give the complement and supplement of each of the angles. So 10 degrees, that's obviously acute, and I'm not going to redraw them. You can easily redraw them yourself. Complement angle is the one that complements it to 90 degrees. So I subtract 10 from 90, I come up with 80 degrees. Supplement is the angle that supplements it to 180 degrees, so I subtract 10 from 180, which is 170 degrees. And the rest is pretty much the same here. This is an acute angle, the 50 degrees, which then comes out to that the supplement is 40. I'm sorry, the complement is 40, and the supplement is 140. 45 degrees, acute angle, complement comes out to 45, and supplement comes out to 135 when subtracted from 180. 90 degrees, that's neither acute nor obtuse. That's a right angle. The complement, of course, would be 0 degrees. The supplement would be 90 degrees. 120 degrees, that's an obtuse angle. The complement is, well, I would say negative 30, correct? Let's see. Yep, negative 30 degrees. And the supplement is 60 degrees. For 160 degrees, that's an obtuse angle. The complement is negative 70 degrees because you subtract 160 from 90. And the supplement is 20 degrees after you subtract 160 from 180 degrees. Okay, next problem. Problem B says, refer to a right triangle, tritriangle ABC with C equals 90 degrees. If A equals 2 and C equals 6, find B. I'm going to switch to Paint, which is a simple Paint program on um, on a normal computer. This is probably the simplest one. So there it is, and it says ABC triangle. So I'm gonna, and then with A equals 2 and C equals 6, and let's see how big I make this here. So I have A equals 2, and then C equals 6, and that should be actually the hypotenuse. So let's see. I'm not sure if this is going to come out to be 6 here. Let's see, 6 would be this much, right? So if I carefully drag it over here, I might come up with approximately here. Okay, and then we're supposed to find the last leg here. There we go. Okay, we have the right angle at C. Whoa, this is really small. Here we go, that's better. Sorry about the strange font here. So here we have the angle C, and then here we have the, ooh, I didn't mean to do that. That's what I mean to do. And here we have the hypotenuse C, and then here we have the angle A, and here we have the angle, oops, that's not true, this is the angle A. This one here, let me get rid of both. Undo, undo. This is the angle A. This is the angle B. And then here we have listed B. That's what we're supposed to find. And here we have listed the side A. I think next time around I will do that triangle a little bit bigger so we can see it easier. Okay, C equals 6. A equals 2. And then we use the Pythagorean. So for B, we're going to come up with the square root of 36 minus 4, or the square root of 32. And I'm not going to show you how to do that. You're definitely supposed to know how to do that. I will use the graphing calculator in later sessions when we actually do need it. What I come up with here is 5.65, or around at 5.7. That's kind of the way I drew it here. It looks like kind of like 5.7. Before I go back to Word, I think what I'm going to do is I just stay here and draw for the next problem C, which says that if B equals 12 and C equals 13, find A. So I'm going to draw B, which it says is 12. Okay, that was unfortunately text, so let's see what we get here. 2, 4, 6, 8, 10, and 12. Then we're going to do the hypotenuse, which it says is 13. So it's a little bit tough to figure out where exactly that is. However, I do know the solution top of my head because the numbers are relatively easy. It will end up right there. So this is 13 long, and we're supposed to figure out what A is. By the way, I don't know if this book here uses counterclockwise or clockwise, or I didn't pay attention to it. Notation for triangles, so if I have it accidentally the wrong way, it really doesn't matter. Let's try to make this a straight line. That means a horizontal line. So we have a nice right triangle at C. And then, of course, here it's going to look a little bit nicer when I do these designations A, B, and C for the vertices. And A and B and C for the sides. Okay, again, on the side, I'm going to calculate how long A is, and it's pretty much hypotenuse squared. You subtract the opposite from that squared and take the square root, so it's going to be square root of 13 squared minus 12 squared, which is 169 minus 144. I happen to have those memorized, so subtract the 2 comes out to 25, and this I expect of you as well, to take the square root of 25 in your head without using the calculator, which comes out 5, which is why I knew earlier that this last length here had to be 5, and that's how I adjusted the hypotenuse. Let's go back to Word and plug in our results. Okay, here we go. I will actually paste this in later on after I'm done with the session, so that you have these available. So let's see. The answer was that B comes out to 5.7, and this is lowercase b, I asked for a side, and in this case A comes out to, Word always tells me start with a capital letter, well, A comes out to exactly 5. Okay, next problem, which says find the remaining sides of a 30, 60, 90 triangle if the shortest side is 3. And it's explained that for this kind of triangle where we have a 30-degree angle here and a 60-degree angle here, there's a proof behind it that when you label one of the sides to be t, then the hypotenuse comes out to 2t, and the opposite side becomes out to t times the square root of 3. So what they have given here is the shortest side is 3, so it would make it t equals 3. And we're supposed to come up with, for example, the hypotenuse, 2t equals, well, 6, of course. That's hypotenuse. The third side is the opposite, so that's t times the square root of 3. And the whole thing will shift right now because I have to borrow that square root. Okay, I'm back. T times the square root of 3. So that comes out to, I'm going to do this on the side here, 3 times the square root of 3. Comes out to 5.2. There you go. Next problem, which says that find the remaining sides of a 45, 45, 90-degree triangle if the shorter sides are each 4/5. So what we have on this one here is t equals 4/5. Whoops, I didn't mean to do that. Well, it means also the adjacent as well as the opposite, both are t equals 4/5. And now on the side I'm going to calculate what t times the square root of, let's see if I still have that square, yep, there it is, square root of 2 is, and so it's going to be 4/5 times the square root of 2 comes out to 1.13, or 1.1, while the other two 4/5, of course, 0.8. Okay. And the last problem is going to be the following. Oops, there it is. There's the last problem. Distance a bullet travels. A bullet is fired into the air at an angle of 45 degrees. How far does it travel before it is 1,000 feet above the ground? Assume that the bullet travels in a straight line. Neglect the force of gravity. That's always nice. Neglect the force of gravity and give your answer to the nearest foot. Actually, that part we like to, well, I don't do it all the time in physics, but if the bullet is fast enough, then you could almost neglect gravity because it doesn't fall as much as it travels up. Okay, let's go to paint. And I have to squeeze that in here somewhere. So we're supposed to figure out, I believe, is actually this one here. So, whoops, I have to go back to straight line, not text. So here's where it squeezes in. 45-degree angle as I go through these squares here, of course, that's kind of convenient. I just make sure that I hit these intersections of on the graph paper. So let's see, and actually I'm counting squares at the bottom, which are the same in the vertical. 6, I'm at 7 now, 8, 9, 10. This is not the diagonal that I just counted, but that's actually the squares at the bottom. 3, 6, 9, 10. I believe I got it right. Anyway, what it says is, you see the 45-degree angle, I hope. So this one here is going to be the height that it goes up. It says it goes 1,000 feet up. So for each little square of 100 feet, 3, 6, 9, 10, yeah, 1,000 feet. And then a 45-degree angle, the hypotenuse would come out with 1,000 feet times the square root of 2. So I'm going to come up with a total distance of 1,410 feet, I believe. Let me check that on the calculator. Yep, sure enough. Okay, 1,414 feet if I really want to. And with that, I'm actually done with this problem section. And I will go back into Word, write this example, the result for this last one down, and then, so let's see, the distance equals 1,114 feet, or rounded 1,400 feet. I actually like that better because the 1,000 feet seem to be a rounded number anyway. Okay. See you in the next exercise section, respectively in the next lecture session.